Bernoulli trials and binomial distribution. There is a collection of defective and non-defective bulbs. Then the probability of non-defective bulb is equal to half and probability of defective bulb is equal to half. Now you can understand this because all are equal in number. Such events are called Bernoulli trials. Now the conditions for Bernoulli trials are: number 1, a finite number of trials; number 2, trials should be independent; number 3, each trial contains exactly two outcomes: success, non-defective, and failure, defective in these cases. The probability of success is same in each trial. Binomial distribution. Consider the experiment of tossing a coin in which each trial results in success, say heads, or failure, say tails. Let us take 6 events in 6 cases as shown. Then the sample space for 3 Bernoulli trials, S, is as shown. The number of success is random variable x. So probability distribution P of x equals to 0 equals probability of no success, which is equal to probability of f, that is equal to probability of f into probability of f into probability of f, which is equal to multiplying q 3 times, that is equal to q raised to the power 3, since the trials are independent. Then probability of x equals to 1, that is probability of one success, equals probability of SFF, FSF, FFS is equal to summation of probabilities of all the 3 cases. That comes out to be equal to probability of S into probability of F into probability of F plus probability of F into probability of S into probability of F plus probability of F into probability of F into probability of S, which is equal to P into Q plus Q into P into Q plus Q into P, that is equal to 3PQ square. Now probability of x equals to 2, that is probability of 2 successes, equals 3p square q, and probability of x equals to 3 comes out to be equal to p cube. Thus the probability distribution of x is as shown. In general, n is equal to total number of events and x equals successes, then n minus x equals failure. Probability of x successes and n minus x failures equals probability of x successes into probability of n minus x failures, which is equal to p to the power x into q to the power n minus x. Thus, the probability of x successes in n Bernoulli trials is equal to probability of x into q raised to the power n minus x, which is equal to ncx into p to the power x into q to the power n minus x, which is equal to n factorial divided by x factorial into n minus x factorial into p to the power x into q to the power n minus x. Hence, probability of x successes equals ncx into p to the power x into q to the power n minus x, where x can take the values 0, 1, 2 up to n, and q equals 1 minus p. The probability distribution of number of successes in an experiment consisting of n Bernoulli trials may be obtained by the binomial expansion of q plus p to the power n, Hence, this distribution of number of successes x can be written as shown. Example: if a fair coin is tossed 10 times, then find the probability of number 1 exactly 6 heads, number 2 at least 6 heads, number 3 at most 6 heads. Solution: the repeated tosses of a coin are Bernoulli trials. Let x denote the number of heads in an experiment of 10 trials. Clearly, x has the binomial distribution with n equal to 2 and p equals to half. So, probability of capital X equal to x is ncx into p to the power x into q to the power n minus x, where small x takes the value 0, 1, 2 up to n. Probability of capital X equal to small x is 10cx into half to the power 10, because here n is equal to 2 and p and q are both equal to half. Number 1. Probability of x equal to 6 comes out to be 105 divided by 512. Number 2. Probability of at least 6 heads is obtained by adding all the probabilities of x having the value greater than equal to 6, and this comes out to be 193 divided by 512. Number 3. Probability of at most 6 heads is obtained by adding the probabilities of x taking the values from 0 to 6, and it comes out to be 53 by 64. Example: 10 eggs are drawn successively with replacement from a lot containing 10% defective eggs. Then find the probability that there is at least one defective egg. Solution: let x denote the number of defective eggs in the 10 eggs which are drawn. Now, since the drawing is done with replacement, the trials are Bernoulli trials. Clearly, x has the binomial distribution with n equals to 10 and p equals to 10 by 100, that is 1 by 10. Therefore, q is equal to 1 minus p, that is 9 by 10. Now, probability of at least one defective egg is equal to probability of x greater than equal to 1. That is equal to 1 minus probability of x equal to 0. So, we get it as 1 minus 10c0 into 9 by 10 whole to the power 10. That is equal to 1 minus 9 by 10 to the power 10. Example: the probability of a man hitting a target is half. How many times must he fire so that the probability of hitting the target at least one is more than 90%? Solution: suppose he fires n times. Let x denote the number of times he hits the target in n trials. Then probability of x equal to r is ncr into half to the power r into half to the power n minus r. That is equal to ncr into half to the power n, where r takes the values from 0 to n. Now, probability of x greater than equal to 1 is greater than 90 by 100. That implies 1 minus probability of x equal to 0 is greater than 90 by 100. That is, half to the power n is less than 1 by 10. So, nc0 into half to the power n is less than 1 by 10. Clearly, half to the power n is less than 1 by 10 for n greater than equal to 3. That implies n can take the values 4, 5, 6 and so on. Thus, he must fire at least 4 times.